I'm going to briefly describe how to use this interactive simulation which demonstrates the Hunter-Nash method for liquid extraction, and I'll lead you through when we look at the simulation. Won't go into all the details as the reasons for what we're doing. There are screencasts that do this in significant detail, but the idea is we have a process with stages. F is the feed that we want to extract the solute from. E is the extract of the solvent with the solute that we've removed from the feed. In this case, S, the solvent, is going to be pure solvent. And Rn, the raffinate, is from stage N. This is the material that has depleted solute, so it's a feed with a lot of the solute removed. And then we, of course, we don't know at the beginning how many stages we have, but this numbering system would be E to the N, and then for raffinate, this would be R1, and this would be Rn minus 1. The simulation allows you to pick one of three feed conditions, and the feed composition is then shown on the plot here. And then the idea is that you can step through each of these four steps here, and it will demonstrate and draw the curves for you. So let's look at that simulation. I'll make it clear what I'm talking about. So here's the simulation. You can see we can pick one of three feed fractions. That's shown here. And in this diagram is showing you when we have feed selected. Now we can select grid to make it a little easier to read off the values, but the feed composition, solute 0.45, that's why the blue line is drawn to indicate that's 0.45. Red line is the solvent mole fraction, anywhere along it of 0.08. And so we can locate the feed point, and I'm going to remove the grid. The solvent is pure solvent, so that's located at the corner, and the raffinate is what we specify of the composition we want to have leaving. Now, a couple things that are specified is that the flow rate, F, is 1,000 kilograms per hour, and the flow rate for the solvent is 1,500 kilograms per hour. So the idea of the simulation now, let's go back to feed. Let's step through the mixing point. It takes the feed and the solvent, and the mixing point has to be on a line between those two. And remember, the feed flow rate is 1,000, solvent 1,500, so these distances are in that ratio. We can locate the mixing point, and therefore this shows the mixing point composition. We can next show E1 by selecting this box, and E1 has to go through that mixing point and through the raffinate Rn. So we now have the locations for E1. The operating point we obtained because of mass balances that relate E1 and F and S and Rn, and those are described in the other screencast on the Hunter-Nash method. So we have the operating point, and then we can count the stages. And so what we're going to do with this slider, first stage, notice there's 4 stages as it turns out for this process. R sub 1 has to be in equilibrium with E1, and so that means it's on a tie line. And then as we continue to step through, we use the operating point to locate E2. So it goes through R1 and E2, and the operating point, all 3 of those points are on the same line. So we have E2. So now we can, again, do the next step. We have to have an equilibrium, and we continue to step through using the operating point and equilibrium for each stage. So we step through final, we have R sub n, and we determine we have 4 stages for this process. So again, the details of why we do it this way are in the other screencast, but here we want to demonstrate the process that we can step through and understand how we arrive at each of these points.